Hello, my name is Pham Nghia, and this is my one-way interview for assignment 3 of the Cloud Foundation course. Amazon EC2 or Elastic Compute Cloud is a foundational AWS service that allows users to launch and manage virtual servers known as instances. These servers are highly customizable, where you can choose the operating system, the number of CPUs, memory size, storage type, and even networking capacity depending on the workload. AWS offers 6 main instance types, each designed to optimize performance for different kind of tasks. First, we have the general purpose instances, such as the M5 and T3 instances. These offer a balanced combination of compute, memory, networking. They're great for a wide range of tasks such as web hosting, small databases, and development environments. Personally, I've used a T3 instance from the AWS free tier to host a basic static website. It was a cost-effective way to get hands-on experience with cloud infrastructure. Second, we have compute-optimized instances. An example of this is the C5 instance. These are built for CPU-heavy tasks that require strong processing performance. They're commonly used for gaming servers, real-time analytics, high-performance web applications, and simulations, which benefits from quick and consistent processing. The third one is the memory-optimized instances. This is designed for workloads that require a large amount of RAM. The R5 instance is a popular option. These are used for in-memory databases, real-time data processing, big data analytics, and they shine in situations where application needs fast access to large volumes of data. And for the fourth, we have storage optimized instances like I4I and D3, providing high-speed, low-latency storage. I4I use NVMe SSD for high read and write speeds, while the D3 focuses on high-capacity HDD storage. These are well suited for data-intensive applications like log processing, data warehousing, or NoSQL databases. Fifth, we have the accelerated computing instances, which include specialized hardware like GPUs or FPGAs. Examples include the G5 for graphic rendering or the INF1 for machine learning inference. These are essential for workloads that involve deep learning, video processing, or advanced simulations. And finally, we have the high performance computing instance, or in short, HPC. A good example is the HPC 6A, which is optimized for cost-effective performance in large-scale parallel computing environments. These are used in advanced simulations like financial modeling and scientific research, where speed and precision at scale are critical. In conclusion, EC2 provides an impressive range of instance types, giving users the flexibility to pick exactly what kind of virtual machines they need. Whether that's a small personal project or a large-scale enterprise application, this variety is what makes EC2 such a powerful part of the AWS ecosystem. To start off, I created an S3 bucket to hold static content I want to distribute. This could be anything from a collection of images or JavaScript files to a full static website. When setting up the bucket, I'd make sure the versioning is enabled if I want to track changes, and I upload all the files that need to be served to the user. Regarding access permission, if I plan to use CloudFront to manage how users access the content, I keep the bucket private. That way, only CloudFront can read from it, which improves security by preventing the files from being accessed directly. Next, I go into the AWS CloudFront console and choose to create a new web distribution, since I'm delivering content using HTTP or HTTPS. For the origin, I select the S3 bucket that I just created, which tells CloudFront where to fetch the content from. After that, I'd set up the Origin Access Control or the OAC. This is AWS' newer and more secure method of giving CloudFront permission to access private S3 bucket compared to the old OAI or Origin Access Identity. I then create a new OAC and attach it to the distribution, which allows CloudFront to serve the files without exposing the bucket to the public. Once that is done, I look at the caching and pricing settings depending on whether I want my content to be delivered globally or just in a few certain regions. This feature would allow me to choose the edge location CloudFront uses, which helps me balance between cost and performance. And lastly, I can set the default root object like index HTML, allowing the users to see the home page when entering. After all of this is done, I go ahead and create the distribution. It usually takes a few minutes to deploy, wait for it, and once it is live, CloudFront will provide a URL to point to the cached content. Before testing the distribution, I'd still need to update the S3 bucket's permission. Since I'm using OAC, I wouldn't need to make the files public. Instead, I'd apply the bucket policy that CloudFront gives me during the setup. This step ensures that the CloudFront has the proper access to retrieve content from the bucket securely. And finally, with everything in place, users can now access the content through CloudFront. Overall, connecting to CloudFront to S3 bucket is a great way to improve performance, security, scale content delivery across different parts of the world. Finally, I want to share how Mr. Steve Wu, whom Dr. Joshua Dwight invited for the guest lecture, has contributed to my learning about cloud computing. His session was packed with real-world insights that connected our in-class concepts to actual industry practices, from the evolution of cloud systems to its astounding achievements and practical advices. Steve's talk gave me a clearer picture of what it takes to succeed in this field. First, Mr. Steve's story about how cloud infrastructure has evolved really fascinates me. He kicked off his career in the late 90s at a startup like Mountain Zone, where scaling meant physically hauling servers to a data center, a process that could take days. He shared how in 1999 their sites crashed when a news story drove massive traffic, showing the limits of those old systems. And we fast forward to his time at Disney, where he used AWS virtualization to spin up virtual machines in minutes, handling millions of transactions daily. Learning how we went from clunky hardware to flexible hybrid cloud helped me understand why scalability is such a game changer in cloud computing. It made concepts in our labs like provisioning resources feel so much more relevant. Next, I was seriously impressed by Mr. Steve's experience in the field, especially his story of achieving 100% uptime at Disney. Managing an API system with half a billion transactions a day, he kept it running without a single second of downtime for 4 years, way better than the industry 99.99% standard, which allows only a few minutes of outage yearly. That showed me how critical high availability is and how teams work together to build fault-tolerant systems. His 20 plus years of experience at places like Microsoft, Disney, and now Starbucks, where he manages cloud strategies across AWS, Azure, and GCP, gave me a glimpse into the real impact of cloud tech. Even when he shared about a junior engineer causing a 5-minute downtime by missing a step during maintenance, I loved how he turned it into a learning moment. His fail fast, learn fast approach made me feel more confident about tackling challenges without fear of messing up. And finally, Mr. Steve's advice for a student like me starting out in cloud computing was super practical and motivating. He stressed sticking to the basics like mastering Linux, understanding concepts like TCP and IP, and picking up coding skills in Python or Go. These fundamentals, he said, are just as critical as trendy tools like Docker and Kubernetes, which he uses at Starbucks to manage edge computing for 10,000 stores. His points about staying curious really stuck with me too, especially when he mentioned how Starbucks needs led to the creation of K3s, a lightweight Kubernetes tool. That really showed me how real-world problems could drive innovation. After his talk, I felt inspired to dive deeper into scripting and exploring cloud platforms with a mindset of constant learning. All in all, Steve Wu's session was definitely a highlight of the course. His insight into cloud evolution and his incredible track record, as well as his down-to-earth advice, have given me both knowledge and excitement to pursue cloud computing. I'm very grateful for the chance to learn from someone who's an industry professional and could show us the way to move forward in the industry. Thank you for listening.